Hello friends, now we are going towards a new topic which is analytic functions in a complex plane. How to analytic function can be defined in a complex plane. You may also call complex plane as a Riemann sphere, since complex plane is topologically homeomorphism with the Riemann sphere. Means same as saying that R square. Okay. Since this is an Riemann sphere, this is in complex plane. Okay, this is in complex plane. Here, this is our n north pole. Corresponding to north pole, there must exist a south pole. North pole is at a point at infinity. Okay, this comes as, and this comes as. This is an x-axis. This is one is a y-axis, this is a z-axis. Particularly, you may also call it the point at infinity. Okay. Now, corresponding to every point on a Riemann sphere, there must exist at least one point on a complex plane. Okay. This intersects the complex plane on the Riemann sphere. Intersecting point. Okay, since you know about the properties of the triangles, okay, you know about this is 1 and this whole area is y, and this is xi3, this one is xi2, this is xi3, xi2, and this is 1. Since y the property of the triangles, you know that this over this and this over this are equal. Means z3 upon y this you may take z2, this may take z3, because this is with the z axis, so it is take xi3, xi2, here xi1, here xi1 along the x-axis and xi2 along the y-axis and xi3. Okay, xi2 upon y equal one minus xi3, means whole of 1, and this portion is xi3, this portion is 1 minus xi3, means this portion is 1 minus xi3 over 1. Okay, over 1 means this portion over this portion, this portion over this portion. Okay, which gives me that y equal xi2 upon 1 minus xi3. Similarly, when we analyze this along the x-axis, we get x equal xi1, because that is along the xi1, 1 minus xi3, and z equal xi1 plus I times xi2, 1 minus xi3. Okay, does its converse exist? You may also take the inverse. Also exist by using the equation of constraints, since x square plus y square plus z square equal 1, equation of constraints on sphere. The equator portion is the unit circle. This is an equator part of the Riemann sphere. Corresponding to every Riemann sphere, every point on a Riemann sphere, there must exist at least one point on a complex plane. Conversely, if you choose any point on the complex plane, corresponding to every point on the chosen point on the complex plane, there must exist at least one point on the Riemann sphere. There are infinitely many points, so n is also called as point at the infinity, and this extended complex plane is called the C complex plane union point at infinity. Okay, its inverse also exists as xi1 equal 2x upon x square plus y square plus 1. Since when you take x here, x square xy1 square upon 1 minus xy3 whole square. Okay, similarly xy2 whole square 1 minus xy3. Similarly this one squares and this one squares, and remaining portion this one. And you can also check, this can also be written as z plus z conjugate upon x square plus y square plus 1, and xy2 can also be written as conjugate upon x square plus y square plus 1, and xy3 can also be written as. Okay, now for analyticity, you know that any complex function f of z is said to be analytic if is said to be analytic if it is differentiable at point z naught, if it is differentiable in the neighborhood of z naught. If you chose any neighborhood around the point z naught, every point means let z naught taking radius as an epsilon, then f of z is analytic if for all x belong in this disk, f of z is differentiable. If there exists at least one point E in this disk, such that this is a notation of such that if there exists at least one point, this exclamation denotes at least one. If there exists at least one point on this disk such that complex valued function is not differentiable on E in this disk having radius, then f of z cannot be analytic on this neighborhood of z naught. Okay, you may also call on z naught as well, because analyticity is understanding portion that it always takes the neighborhood, not only a single point where we can check the analyticity of certain complex valued function. How can we analyze that whether the function is analytic or not? Since z conjugate equal x minus I by, when this involved in any value or any function, that function cannot be analytic, because the Cauchy-Riemann condition cannot be satisfied in this form. You can also check by assuming the Cauchy-Riemann conditions. Okay, check whether y upon x is analytic. Check whether f equal y upon x is analytic. No. Why? Because z minus z conjugate, z plus z conjugate will be involved here, so it cannot be analytic. Whether it is analytic? No, because imaginary part cannot be appeared. It cannot be analytic. We can say that it can be written is in the form of z plus z conjugate upon 2. Okay, so this involved in this portion, so it cannot be analytic. Whether when you check the polar form, whether r e iota theta, okay, where r equal x square plus pi square wholly root and theta equal tan inverse y upon x. Okay, you know that x square y square can be expressed is in the form of modulus this, so it cannot be analytic as well. Okay, this cannot be analytic, by because z modulus whole square will be involved in this portion. Okay. Similarly, you may miss and tan inverse by upon x. Since you know that by upon x can be expressed in this form, and what is this? Conjugate will be involved, so it cannot be analytic as well. It can be written as z minus conjugate, z plus conjugate. Okay, conjugate cannot be involved. So check whether e to power z is analytic or not. Yes, it is analytic. By it cannot be expressed in the form of z conjugate. It is analytic everywhere on the complex plane. It is also an entire function. It is also an entire function because it is analytic everywhere on complex plane. Okay, and it maps onto a circle on the omega plane, so it is analytic. Ex plus I times by ex ei e to I to by ex equal cos by plus I times sin by. This portion maps into the ray in the omega plane, and this into the omega, and this portion mapped onto the circle in the omega plane. Okay.